It's good. Okay. So, okay, let's start. So my name is Ricardo. So I'm actually doing this talk on behalf of Spiros, who is the PTL of Magnum. So I'll try to give an update on the status of the Magnum project. I'll go first through what Magnum is. Magnum is an OpenStack service that provides an API to create and manage container clusters. They are deployed within one project, one tenant. They manage things like the credentials so that you don't have to do it yourself. You can use your OpenStack credentials to generate the credentials that you will use to talk to the clusters using the native APIs. That's another point. It manages all the OpenStack integrations. So if you want to include, to use from inside your clusters or containers, access Cinder, or use Keystone credentials, it does this for you. And it also manages lifecycle of all the clusters. So one of the features is also that it supports different container cluster engines. So here I list the ones that are supported: Kubernetes, of course, Docker Swarm, and Mesos and DCOS. So here's a quick example of how this looks. The clusters are described by what we call a cluster template that defines things like which engine should be used, Kubernetes, Swarm, Mesos, what size the masters and nodes should have, which version of the engine you want to use, and many others. There's a lot of configuration. If you go to documentation, there's a large amount of options you can use to define your templates. The templates can be public in the sense that an operator can define them and make them available to all their users, but users can also customize them and create their own templates. Lots of details about how a cluster looks. So you can configure things like the size of the master, the flavors of the masters and workers, also the number of masters. You can have a multi-master cluster and the number of nodes you want. Internally, they are deployed as heat stacks. They will have a trusty user inside that does all the interaction with the OpenStack APIs on behalf of the user. You can have things like your custom, each cluster actually has its own certificate authority, and this can be stored in the Magnum database, but you can also use Barbican if you have deployed in your cloud. So I mentioned there's multiple orchestration engines. You can also have multiple backends for the nodes, multiple operating systems. You can't use all of them for all the drivers. So there's a matrix that tells you which ones are supported. The most used are Fedora Atomic. In most cases, it's Fedora Atomic. You can deploy clusters both in virtual machines and bare metal using Ironic. And then there's like more advanced functionality. Once you have the cluster, of course, you have to manage it. You need to extend it, reduce the size of the cluster. So you can do this using scaling. And also there's Ceilometer integration if you have it in your cloud. A quick example of how this looks. So if you want to create a cluster, you have to specify the template you want to use, in this case Kubernetes, the flavor for the nodes, large nodes in this case, the number of nodes. Then you issue, once it's ready, you issue one command to fetch the credentials that will allow you to access the cluster using the native APIs. So this config command will actually generate different output depending if you have a Swarm cluster or if you have a Kubernetes cluster. So this is one main feature, is that then we don't have an extra API. You just use the native API. We just orchestrate the cluster creation and management. There's also a lot of functionality that is supported within the cluster. So things, this is an example for Kubernetes. Along with the deployment of Kubernetes, you also get things like the Kubernetes dashboard. There's an InfluxDB, Grafana for more detailed monitoring. There's a lot of extra bits that we deploy along with the cluster that are very useful to get a full experience. So this was a quick overview of the project. I go now to the main features that were released in Queens. Mostly, the main one was actually the most requested feature, which was to be able to customize the clusters on creation without having to define a new template. So one common use case, you have a bunch of public templates published by the operators, and you want to do a small modification to the public template, and you actually had to create a new one, which was kind of cumbersome. So now you can just override some of the parameters in the template at cluster creation. So things like the master node flavor, the volume size, if you're using Cinder volumes for the Docker storage, and any labels. So labels, there's a large amount of labels that you can customize the clusters. You can also override them cluster creation. You can also specify availability zones. So you still can't have like one cluster spanning multiple availability zones, but you can say which availability zone your cluster should be deployed in. So if you need high availability, the way to do it is to deploy multiple clusters, one in each availability zone. Then some specific features on Kubernetes. Calico was added as a network driver so that you can define network policies. So if you use network policies in Kubernetes, they are now implemented if you're using Calico. RBAC is also supported. And then there's a kind of a new monitoring stack for Kubernetes that deploys Hipster and the Kubernetes dashboard, but also an InfluxDB with a Grafana on top. Another big feature was inclusion of an ingress controller. So there's traffic, and there's ongoing work to also allow Nginx, both with and without TLS support. And then new versions of Kubernetes being supported. So there's support for 1.9 and 1.10. The other thing that happened during this cycle is that the deployment moved completely to using containers even for the Kubernetes components, which means that actually upgrading to a new version of Kubernetes is just a question of changing a tag in the template. Sometimes it needs a couple more changes, but this is changing. It's quite stable now. For operators, you can easily just change the version in the label, and you will get a newer version of Kubernetes. On the more operator side, so you couldn't before list or show details of easily of your users' clusters. So now you can. There's full access for admins. You can also specify a custom CA. So if you're deploying clusters and you're using a specific CA from your organization, you can specify so that it's recognized and you don't have to do funny things and recognize the CAs. You can also, so the cluster driver, the way it's deployed also changed. There's a lot more flexibility on how we are deploying the components on the clusters using the heat agents, instead of just passing everything in the Nova user data, as we reach a limitation on the amount of stuff we can pass in the user data in Nova. So this was changed to use the heat agents instead. Looking forward, so these are the main goals for Rocky. So it's quite a big list, but some of the work had already started in previous cycles. So this is what we hope to have done by the end of this cycle. The first one, one of the main ones, is cluster upgrades. I'll give some more details after. Cluster node replacement. Some of the users have asked to do manual node replacement on their cluster, but the main feature here is to actually monitor the health of the cluster. So there's some work already being pushed to monitor the health of the cluster. Like if you think of Kubernetes, it does its own health monitoring of the cluster, and it publishes nodes as ready or not ready. So Magnum will use these APIs from the engines to also understand if the clusters are okay or not and provide feedback to the users. Also give some details on that one. Integration of keystone authentication in Kubernetes using RBAC and the cloud provider. Cluster log collection using FluentD. So there will be also an optional deployment of FluentD along with in the cluster to aggregate the logs, and you can then configure it to publish outside the cluster if you need it. Like if you have an Elasticsearch in your cloud, you can just forward all the logs there with one configuration option. Support for federation. So we talked, there was a couple of talks already about this. It's a generic API, but the implementation, at least the first implementation, will be Kubernetes only. But if other engines eventually support it, this can be added. The selection of the availability zone I mentioned. And then, yeah, so Docker itself is now running in system containers. It will come in Rocky, but the work is already done. So you can also upgrade Docker in place as it's running in a container itself. So one feature that we added recently, and because there's so much talk about like better isolation for the container workloads using things like gvisor and Kata containers. So one feature that will be worked on also during this cycle is to choose the container runtime. So right now you can't. There's a default one, which is Docker for Docker Swarm, and it's also Docker for Kubernetes, but you'll be able to choose which container runtime you want to use. Things like Docker, which is the default right now, but also Cryo, Containerd, and eventually gvisor and Kata. So a bit of details on the on two of the features. So cluster upgrades is a big one. There's two main use cases, and we see both on the usage of Magnum. One is workloads that are short-lived. So people create their cluster and use it for a week or two or maybe a month, and then they destroy it. So they do some data analysis or something. And in these cases, upgrades are not that relevant. But for long-lived services, this is required. So this is most of the work has been done already in this cycle. So we're pretty confident this will come with the release of Rocky. There's a couple of options. So there will be different upgrades for the masters and the nodes, so they don't have to be done at the same time. This is very similar to what GKE offers, for example. So you can trigger the upgrade of the master and then have a window to do the actual upgrade of the nodes. That can be, and this action is triggered by the users, so they can decide when it's best to do it. The upgrades are done in batches, so it's not in one go. They will be done by doing node by node or batches of nodes. The way this is also being done is that the nodes are drained to make sure no workloads are left there, and then you can either rebuild the node or do a complete replacement. This depends a lot on how your cloud is configured and the networking on the cloud, but rebuild or replace are two options available. And I think that's it regarding upgrades. The second feature I'll mention here is cluster healing. One of the problems with Magnum right now is that once the clusters are deployed, there's very little feedback to the user on the existing status. They can get the status using the native APIs, but there's not much from Magnum in this respect. So what we started working on is to have an additional state which will tell a user if the cluster is healthy or unhealthy. There's not much magic inside Magnum. We just rely on the container engines themselves. So again, we just ask Kubernetes what Kubernetes thinks is the status of the nodes, and we report this back to the user. But what we are working on is actually having the possibility to trigger actions. So eventually you will be able to define on cluster creation if you want to have auto-healing of the cluster. If this is the case, whenever, for example, Kubernetes will decide that the node is unhealthy and not ready anymore, Magnum will do the replace or rebuild of the node itself, so that the user doesn't have to deal with it. The other option is that we just report to the user, and then it's up to the user to do the node replacement manually. So both will be possible. The other field there is the reason, so there will be some feedback to the user regarding why this action was taken and why the cluster is unhealthy. So this is the update for Magnum, and I leave in here the details on the, how you can give feedback, how you can join the development if you're interested. So we use the standard OpenStack tools. So, and all the contribution repositories, most of the developers are in IRC. So if you have questions, the channel is OpenStack containers, and you can join. And that's it. So if anyone has questions, I'm happy to try to answer. Yep.
I found from the current Tempest plugin, there's no test cases for the functionality of Kubernetes or Swarm itself.
Yep.
How you guarantee the functionality of the COE is correct or not after creating the cluster?
Right. So this is mostly the tests exist, but they are not enabled on the tests on the reviews. Mostly because they time out when they are run in Zul right now. So there's some work on somehow finding a way to get this done better. It's mostly a question of downloading the containers and making them available when the clusters are deployed. So the way this is done right now is that a couple of developers are doing careful tests offline before merging things. But yeah, there's some people looking at enabling these tests. But even if they are not enabled in the reviews, they are being done before being merged somehow. Yeah.
Okay, thank you.
Yeah.
Hi. What mechanisms are you going to use for the cluster upgrades in place? Like, what is going to be actually doing that work, and how is that accomplished?
Right. So one of the big changes with Queens was that everything was moved into containers. So, for example, giving the example for Kubernetes, the API server, controller manager, even the kubelet are all running inside containers. So the way the upgrade in place is being done is these are atomic system containers. And this, we are upgrading those containers and then just restarting the systemd service that will just replace the container in place.
Okay, so this is not using something standard like the kubeadm process?
This is not using kubeadm, yeah. We just deploy using everything using system containers. Then that's for the in-place upgrades. The other option is to do a full replace of the VM. In this case, there's a drain of the node. We wait until the node is fully drained and all the workloads are moved elsewhere, and the node is completely replaced.
Thank you.
So there's a new deployment. I actually discussed this with the Google Cloud people, and this is how they are doing their upgrades too. They do a full node replacement with a drain previously. Yeah. Okay, so if no further questions, thank you very much.